For this next type of question, you can just think of it as a pattern. If you're given 2 points, 4, 8, and 6, 32, you gotta think. If 4 is the x, it goes with 8 for the y, and then 2 spaces later, you're at 6 and 32. So something happened twice because it went from 4 to 5 to 6 for x, and it went from 8 to something to 32 for y. So since the x's had a change of 2, then the y's you would want to also multiply by something twice. Times something, and then times something. This one's actually pretty easy because between 8 and 32, you could fit 16, and then for 8 to go to 16 would be a times 2, and then for 16 to go to 32 would also be a times 2. So that would mean that this missing part k would be 2. And the missing x would have just been 5. From 4 to 5 to 6 would be from 8 to 16 to 32. There is another way we can do it, but since this one was simple, let's just keep it like that. Okay, this k here, the k is what we multiplied by. K is what multiplied. Each time x changed. And if you look at the formula, x is attached to b, so this k, which is the number that we multiplied by, we did times 2 and then we did times 2 again, that would mean that 2 was the base for the x. So we have y equals something times 2 to the power of x. Now that we can see how it changed each time, it multiplied by 2 each time. Then we can plug in another point. We can take these numbers, plug them in for y and for x, and we should be able to solve for a. The y is 32. A times 2 to the power of 6. 32 equals a times 2 to the third power is 8, 2 to the fourth power 16, 2 to the fifth power 32, which means the sixth power is 64. Since a is the only letter we don't know, then we'll divide by 64, and we get 1/2 for a. Now that we solve for a, let's just finish up this equation. Y equals 1/2 times 2 to the power of x. Let's check this with the second point and make sure that it works. 8 equals 1/2 times 2 to the power of 4. That would be 1/2 times, I already wrote down the 2 to the power of 4 earlier. 2 to the power of 4 is 16. 1/2 of 16 is 8. So when we solve the right side of the equation, it gave us 1/2 of 16, which is 8, which is equal to the original y from the start of the question. So this method of solving works. To summarize the steps, we took the ordered pairs 4 with 8. We wrote them so that 4 matches with 8, 6 matches with 32, and I left some space in between because something happened between 4 getting to 6. So at first, we didn't know what these center numbers were, but we just knew somehow we went from 4 to 6. And that happened by 8 changing for 2 steps worth. We did multiply by something, multiply by something. For 8 to multiply twice to turn into 32 would be a times 2 and then a times 2. And then we were able to fill in the missing spaces to get that k is 2. K is the number that we multiplied by in between each step. That number that you multiply by is called the growth factor. Since we're multiplying by 2, that means we're growing by a factor of 2 each time. Once you know your growth factor, then you can plug in either one of the points, the 4 for the x or the 6 for the x, and then whatever the y is, you put that on the y side of the equation for the formula. And then you solve for a, and then you check and make sure that your a works for both points. Okay, let's do another. I'll try it the same way just to see if it works. If it doesn't, we'll come up with a new way to make it work. 2 goes with 18. 5 goes with 60.75. So we should be growing. We moved forward 1 space, 2 spaces, 3 spaces. So we have to multiply, then multiply, then multiply. We're multiplying by the same thing each time. For 18 to multiply, it's not going to be a straight number. Like, it can't just be like times 2 or times 3. Since this is a 60.75, there's some sort of decimal mixed into here. Okay, so we're multiplying by the same factor each time. I'm calling it k. If 18 is multiplying repeatedly by k, and somehow it turns into 60.75, then we can write it like this. 18 times k times k times k equals 60.75. That means 18 times k cubed equals 60.75. And then we can divide by 18, so that k is by itself. To get k cubed equals 3.375. And then to solve for k, we'll do a cube root. Since the cube roots are way in the function table, I'm just going to write 3.75 to the power of 1/3. To get k equals 1.5. If k is 1.5, that means we did times 1.5 times 1.5 times 1.5. So the number that we did repeatedly was times 1.5, which means we multiplied by that multiple times. So in the formula, y equals a times b to the power of x. This part that's repeating, the 1.5 is repeating, which means it is the number that gets raised to a power. Y equals a times 1.5 to the power of x. And then the next step is to solve for a. To solve for a, you can take either one of these points, and since 218 is a nice and pretty point, I'll use that one. Use a point to solve for a. $18 equals a times 1.5 to the power of 2. To save us some time, since we're going to use a calculator anyway, I'll just divide by 1.5 squared. Divide by 1.5 squared. It'll cancel on the right side and give us A. So I'll just type 18 divided by 1.5 squared, and we get our A. A equals 8. If A is 8, then that means y equals 8 times 1.5 to the power of x, and then we'll check it with the second point. 60.75 equals 8 times 1.5 to the power of 5. And then we'll put that right side, this side goes into Desmos. And if the number on the right side turns out to equal 60.75, then we have the right answer. I plugged in 8 times 1.5 to the 5th power, and we get 60.75. And that comes from the right side. The right side was equal to what we had on the left to start with for the y. So that means there were no mistakes, and our equation works. Pause the video, try this one on your own. And here's how I would solve it. They gave us 84 million in 2000. We're going to grow by 34% until 2005. They want an equation, and then they want us to figure out what the actual number is in 2005. So this means we start in 2000, and then we end in 2005, which means the x from the start to the end is going to change by 5. Since we only changed by 5 years, make 84 million the starting value. And make 2000 be x equals 0. You get to pick where the starting point is, and since 2000 is the earliest thing that we have in this situation, and we're not going backwards in time, it's fine if we just pick 2000 as the 0 point, the start of our graph. That means 0 goes with 84 million. And then we need to figure out what number goes with 2005 is 5 years later. And we can get this y just by plugging in to the formula. A times b to the x. A is the starting value. So we'll put 84 million right there. B is the growth factor. And they told you our R was 34%. So we'll convert that to a decimal to make 0.34. You take that 34%. That's how much you're adding on top of the original. So you do 1 plus 0.34, and that'll be equal to B. 1 plus 0.34 is just 1.34. So instead of writing B in that bottom equation, I'll write 1.34. And then we'll plug in the x as the 5th power. Now I just gotta type this in a Desmos and get my answer. We do end up with the decimal of 0.762. And since the original situation is talking about the homes that used internet, we won't round that number up. So we'll just leave it as 362,913,628 homes with internet access or internet use in 2005. Thank you for watching. If you need more help, you can watch the next video, which will be about exponential decay. It'll be pretty much the same ideas, except instead of growing, we'll be shrinking, which means instead of adding r, we'll be subtracting a certain r, which means every time you multiply, you get to be a smaller number.